Good afternoon, everyone. My name is Oleksandr. I work at Pivotal on Cloud Foundry Container Runtime, which is highly available Kubernetes installation.
Hi, my name is Eric Johnson. I work at Google, and I lead a team of engineers working on open source integrations for GCP. And we got our wardrobe malfunction today, apparently. So when Alex and I were looking at putting together this talk, the title of it is All You Need to Know to Deploy an Application on Kubernetes. So we took a step back and we thought really hard about how could we sort of distill this down to something very basic and easy for you to understand. So we put a lot of time and effort into this, and this is what we came up with. So there it is. That's all you need to know to deploy an app to Kubernetes. So if we could have everybody kind of come forward, if you can't see, we're going to wait about 20, 25 minutes for you to read this and then take questions at the end. Is that good? All right, probably not. So what we did do, though, is take this as kind of a starting point, and we have a sample application. But again, the title was All You Need to Know. But we kind of, the fine print on this is it's not really all you need to know. There's a lot of other things that we're probably going to assume you've had some basic experience in. So you know what a container is, you know what an image is, repositories, things like that. So we'll kind of just skip into the details of what you would need to actually deploy an application onto Kubernetes from that great big wall of YAML that you saw. And distill that down into sort of three main concepts. And then we'll just kind of work through that YAML as we go. So what we're actually going to cover is how do you deploy an application, how do you access it, and how do you keep it running. And the application that we picked, has anybody used Spring here before? So I see 2 or 3 hands at least. Cool. So this is a Spring conference. We figured we'd use the Spring Music, which is Spring Boot app. Typically, everybody's seen this deployed to Cloud Foundry, but we figured we'd go deploy it to Kubernetes instead, just because it's a Kubernetes talk. So I think we're going to have Alex do a little bit of a demo just to kind of kick things off, and then we'll come back and talk a little more.
So, yeah, didn't clear. Okay. So what we have this big YAML file in this manifest, as I called it. It's the same YAML, multiple screens, all the same. What I will do, I will run magic command, kubectl apply this file. And this will make it deploy.
Great. Any questions? Sorry, that joke's going to get old, right? All right, so what are we going to do next? We're going to start off with how do you deploy an application. So let's go back to that YAML manifest and take a look at some of that and figure out what parts of it we need for a deployment.
So first, image. You need image to start container, and we'll create this Spring Music image. It has to be versioned. It has to be versioned in the way that you don't overwrite versions anytime. So when you release this version, if you want to release next iteration of application, release new version of the image. So the version stays immutable. So you can run it usually on local machine. And yeah, image, that's the first thing. And from image, you can create container, which requires name and image pull policy. And this is why you need a versioned image because when you scale, Kubernetes will pull the image again. And that means that if you replace the image, you might have multiple versions of same application running, which you don't want usually. So you can think of container as a single running process. And you need to configure it, obviously. Like Spring App, you need some configuration. So I've done some simple configurations. Environment, it's one of the 2 configurations. It's with environment variables. You just pass as a map, simple map is name, value. And otherwise, use files. So in this case, I show the example of so-called config maps. I pass this file to the disk with application properties and create some various sample application property with config map.
So I have a question. So we talked about we need an image, and we're going to wrap that up in a container. We're going to configure it, right? And part of our application, you showed 2 different ways of configuring. One was with an environment variable. The other one is with configuration files. Do you have any suggestions on Why would you do one versus another?
Yeah, so with environment, environment variable stays in the container, first of all, it's promoted, and second, it's in the deployment manifest. And as for files, you can separate them and configure them separately. And one more nice thing is that, for example, with config maps, there is Spring Cloud library that lets you, not lets you, but automatically deploys the application when you change the config map. So you change some property, applications get automatically redeployed, which is handy. So you configured it, you configured the single process, and now you want to run not just single process, but the minimal runnable entity of Kubernetes called pod. It's usually multiple containers running together, so they usually talk to each other using shared files. It's one of the most common ways. You don't have to have multiple containers, but if you need to have something that, for example, caches data from the internet periodically, like in this example, or another use case is use some kind of sidecar. So you can read about Envoy, maybe you heard of it. So it will do like some proxying, some certificate termination. You can use it with extra container. The one important thing is that you need to, like, in the pod, you just put separated part of your application. You don't put your application database in one pod.
I was Googling a little this morning about what Kubernetes was, and I kind of came across that fact, that a good way to package up your containers is separation of back end and front ends. So I think this is a good example where within the pod, you're going to focus on your front end stuff. Those containers go into one pod. Maybe your back end stuff that's talking to a database, you go into another pod, right?
Yeah.
And then you can scale those things independently. Cool.
So then,
oh, but that's a good point.
Yeah.
Right? If we want to migrate a database or something like that, there's typically things that you want to do before you do a next version of your application, right? So how would we go about doing that?
Yeah, this is this concept called init containers that run before, at the beginning of starting each pod. So you just specify some image and command that will run, and as soon as it ends, actual pod startup, pod will actually start the normal containers, that long running containers. The one thing that you need to remember that this init containers needs to be able to execute multiple times and not crash and execute them in parallel, because you might execute multiple pods at the same time, and if it can run in parallel, it will crash again. So with all this, you have single pod, and the main point is that don't use pods directly. That's important fact.
So all that stuff that Alex just told you about, now he's telling you to forget about it. I don't really follow Alex. Come on.
Yeah, not really forget.
Okay.
The thing is that pod is minimal built-in block in Kubernetes. So Kubernetes deploys everything using pods. Every process that will run, it will use pods. And pods is the main identity, and then API is built on top of pods. So if you see some other things that run on top of Kubernetes, they use pods underneath. And you will use pods underneath, and you need to know how to configure it and do it. And you'll basically copy all the pod configuration in part of other configuration. And one more thing, that pods are ephemeral. So it's like single pod, it starts, then it might crash, it might die at any given point, and it will get, if it's on the same node, it will get restarted. If it's on a different node, it won't get restarted. So you need to think how to keep them up and running. And for this, Kubernetes provides a concept called Replica Set. It makes sure that at any given point of time, some amount of pods and known amount of pods is running. So that way, if one pod crashes, it will start another pod, and this will run. The one thing is that Replica Set is also static. You can change images. For example, for pods on the Replica Set, you can only scale it up and down. So if you want to use something like blue-green deployment, you have to use other thing called deployment.
Deployment. That makes sense.
Yeah. And you see most of the definition is deployment, and YAML allows you to specify multiple documents in single file. That's what I use, so this is like one single YAML document all about deployment. This is what you want to use. What it basically does, it creates replica set and scales to specific amount. And when you upgrade your deployment, it will create another replica set and start scaling it up and scale down the initial replica set. And that allows you, deployment also allows you to roll back, and it's very nice to use. So that's what you need to use, what 99% of the cases you need to use. But there's obviously some percent of cases where you need some state for your application, you need your disk attached to your application, or maybe your application have to start in specific order. For these cases, Kubernetes provides Stateful set. I won't cover it here, you won't cover it here, but just remember, it's possible. So with deployment, we deploy application.
Great. So we've got that part covered. So now we're going to talk about how do you access this. So that's nice. You've got this Kubernetes cluster. You've just deployed this application to it, but you really want users to be able to use it, right? So how do we go about doing that?
Yeah. And for this, Kubernetes provides the concept called service. You can create internal services with static IPs inside the cluster and external services with node port or load balancer type.
So there's you said internal and external services?
Yes.
Yeah.
Yes, Eric. So internal services, let's go back a little bit. Pods are ephemeral, as I said, and pods have IP address, but they can crash, you can scale them up and down, and when pod get deleted and created again, they have different IP address. So if you want to connect to your application, like front end to back end, you need to know, you need a way to access this application. And in general case that the IP address will change. So service is this nice abstraction that will create the special IP address for the service that your application can access. And at any given time, it will get resolved to the pods that are running. So this is why you need internal services to access from other pods, from one pods like front-end pods, your back-end pods. But for front-end, you also need to access front-end, and you need to expose this somehow to the internet. And one way of exposing it is to have node port. What it does, it opens the port on the all worker nodes, the same port on all worker nodes, and then when you try to access this port, it will forward traffic to the service IP, and from that service IP, it will get to actual pods. And on top of it, you can create load balancer, which will create load balancer in infrastructure of your choice, and obviously GCP. And forward it to the opened node ports on the worker VMs, and then from that goes to service. So it builds on top of each other again. This is how it's usually done in Kubernetes. Things are built on top of each other. So yeah, after this, you can access your application.
But how do you make sure that it's going to stay around, right?
Yes.
So you said, you talked about like pods being ephemeral. Mm-hmm. You've got replica sets that are going to keep a certain number of them. We've got a way with using services to be able to make sure that front ends can talk to back ends or that the app is publicly accessible. But if something goes wrong, how do we know?
And that's a good point. So one thing that pods are added to the service when they are ready. And by default, ready is when container starts. But with Java application, it takes a little bit more time than just start container. It will take some time to actually start serving traffic. And this way you can use readiness probe. It will run some command and try to access your web service or check the file on disk or something and check if it's successful, then pod is ready and can serve the traffic. And this is where you can use actuators from Spring and then add your own actuators and check if it's healthy, then start serving traffic. So after this, your application is highly available because it's available to the internet and available only if it's running pods.
But what if it's so we're talking a little bit about how to keep it running. You've got these things, you've got these different pods running on different machines, right? But there's probably going to be some issues there in terms of how those things get scheduled, right? So do you have any kind of, are we going to talk about like how do you make sure that everything is going to be available even though the machines might move around a little bit?
Yeah, we're going to talk
so
about
we have,
this.
right, we said that back in the replica set.
Yeah.
We want 3 of these things. They all could potentially land on the same virtual machine, which is probably not a good situation to be in if that VM dies, right? So we want to kind of have these things spread out a little bit.
Yeah.
Tips, tricks, what do you got?
I got affinity rules, so the affinity and anti-affinity rules, and you can, this is basically example from documentation, how to spread out your deployment across cluster and deploy it on different nodes. And you can also, this required, and it's also preferred, you can do that. It will try to scale on different nodes, and this will force it to scale on different nodes. And one more neat thing that it has, it can not only replicate different VMs, but can replicate different AZs. Depends on node label. You can label node and add multiple labels. So there might be availability zone, there might be VM types, there might be some hardware like GPU, and you can put pods on specific VMs.
Right, so we have a feature enhancement for our Spring Music app. Now when you click on that, there's some pretty fancy visualization that happens, and we wanted some GPUs for that. So we have a part of our cluster that has GPUs and a part that doesn't. So we could use this, right, to direct like where those pods that are going to have those visualizations land, right?
Or analytics, crazy analytics.
Oh, okay.
Yeah. Data science. Okay, so one more thing that during the upgrade, cluster upgrade, not the deployment upgrade, sometimes it might happen that 2 of your pods will end up on the same node if you don't use the anti-affinity rules. And you don't want them to, if node goes down, both of the pods go down. You can use this pod disruption budget that will say that you can say at least some amount of pods should be running, or at most some amount of pods should not be running. And this is how you can control it. And one more thing that it can be applied since it's applied with labels, you can apply it not for only one deployment, but for multiple deployments. For example, if you have like, I know, V2 and V3 API, you can say that at least 5 pods of API should be available at any given time, and when you upgrade, there will be downtime of one of API, V2 or V3, but not each of them. So with all that, you'll be ready to stop the application, and here where you need Graceful Shutdown. So one thing that you need to handle stick-term signal, because it's sent when the port, when you delete the port.
And it integrates well with Spring too, right?
Yeah, I think it's the support for SIGTERM is built in Spring. And if your application requires some other thing, you can obviously add more integration. And one more thing is pre-stop hook. If you need to run some command on the container, you can run this pre-stop hook. It will run this command, and only after that, it will get the SIGTERM signal. The one thing that there's grace period, so time from which pod receive delete command and get the kill process will get kill command, and pre-stop hook is part of this grace period. So you need to be careful not to run some very heavy pre-stop scripts.
That's nice for the graceful shutdown,
Yeah.
right? But are there other conditions where like this thing's just not responding, and you want to go in there and be mean to your application?
Actually, you don't want to go there. You want Kubernetes to go there for you. With liveness probe, which is similar to readiness probe, it checks if your application is responding, and if it's not responding, then, as Eric said, kill it and start another pod. And usually, because you started pods before, it will create another pod and everything will stay running. One thing that's important, especially for Java applications, is that you need to have big initial delay, because I had one support case where applications were crashing all the time and they weren't able to start. They will fail in the liveness probe and get killed and continuous recreations.
I thought we had agreed that we weren't going to bring up that support case because that was when I was learning Kubernetes and I got into a bad state and I called up my good friend Alex. So he keeps bringing up this story. It was kind of embarrassing.
I thought it was about Replica story. But okay, so with all this, I think it's minimal for what you need to deploy highly available application on Kubernetes, but that's just beginning. So there are more topics that you need to read. So, for example, learn about secrets, how they start in Kubernetes and how you can use them. Learn how to autoscale application using horizontal pod autoscaler. Learn about pod security policies, how Kubernetes operator can prevent your application using some features. Also, resource limits, how to limit your application so it won't use too many resources, or if it will get deleted. And how to make sure that your application won't get deleted if it's very important, but some other application get deleted with pod priority class. Also, class DNS is quite neat feature that provides DNS name for your services, and this way your service can be used on different clusters with the same name. Simplifies configuration. And the last but not least, to access applications, you can have only one entry point using ingress controllers, and then it will forward everything to different services. Okay. Oh, demo. So let's check kubectl.
Right, so we did if we talk about those three things that we were going to walk through, right? We did a deployment. So this is using the kube. I would love to take a vote. How many people say kubectl, kubectl, kubecontrol? I don't know. Never mind.
No.
We use this command to list out the deployments, and we should see one.
Yeah, one is there, so we can get resource set. One is also there. We can get kubectl get pods. 3 pods are running, and we can check that they're using different
So
nodes.
this is how we know it's running, right? And it's available.
Yeah, so you can see different node names, and you can do describe pod and see. It should tell you the probes. Spring 5. So it's unhealthy. Oopsie.
Well, that's part of the demo, right?
Yeah. Anyway, kubectl get svc. Maybe it wasn't healthy. We'll check it. Anyway, it should be available on this IP address. So Spring Music, it's good. And I can go to actuators info. Same IP address, interesting. So if I zoom it and I search for something, it's environment variable that I added, something, and with value. So you can use it in your application if you want. And one more thing is, with this application config, I added Spring Music and Spring 1 demo config value. So this is how you can access it with these 2 properties and put there whatever you want. Yeah, I think that's it.
Yeah, so that worked. We're not going to show off that feature about the GPU and the visualization stuff. Yeah, we're kind of out of time, so we didn't actually do that. So you want to try this out for yourself, right? The first thing you're going to need is a Kubernetes cluster. A couple options here for you. Obviously, you could use Google Kubernetes Engine. I've got a link there. If you've ever used Google Cloud Platform before, you could get started for free. You can also swing by the booth. We'll probably give you extra credits if you come and visit us. So you could do that. There's also the Cloud Foundry Container Runtime project. part of the Cloud Foundry Foundation. And I think if you stick around next, after this, there's another talk about CFCR, so you can learn all about that. And then, of course, you can create a pivotal container Kubernetes service cluster as well. So there's a link there for you to get started with that. Alex was kind enough to post that wall of YAML for you, so you could just download that and kind of try it out for yourself. And then he also posted the slides.
Yes.
So and with that, I think we're pretty much done. So thank you very much. I hope you learned a little bit. Thank you.
Thank you.